Hello everyone, welcome to the 13th tutorial class on neural network and fuzzy logic control. And this class will be presented by myself, Dr. Sudip Mandal, Assistant Professor of Department of Electronics and Communication Engineering from Jalpaiguri Government Engineering College. So coming to the content of this class, basically in this class we shall discuss another very important topic, that is recurrent neural network or RNN. In this class, apart from the theoretical operation of the RNN, we shall also discuss different application and the detailed operating principle of it. Okay, so let's move on. So first of all, before going to the theoretical concept of RNN, let's discuss what are the different issues that occur if we use feed-forward neural network. Basically, in case of feed-forward neural network, which is preferred whenever we go for the general regression and classification problem. Okay, so in case of feed-forward neural network, one layer is connected to the next one, and the weight to the each layer are independent to the previous one. That means there is no memory in it. Okay, so for this purpose, multi-layer feed-forward neural network or MLFFNN suffers from um, following problems. First of all, it cannot handle the sequential data. As you know, if you consider the sequential data, the present input or present data is dependent on the previous input or the output. So whenever we want to predict the sequential data, that means that varies according to the time or varies with the time. Normal feed forward neural network cannot handle it. Okay, as it uh, only depend on the current input, not the previous input. Okay, so for that reason, feed forward neural network is not suitable for the prediction of the sequential data or the time series data, because again it cannot memorize the previous input. Okay, so these are the some major disadvantages of feed forward neural network whenever we want to deal with the time series or the sequential data. So to deal with the time series data or the sequential data, recurrent neural network is preferred. So basically, RNN is one type of neural network where the output from the previous step are fed as input to the current step. Just remember this term, that the output from the previous steps are fed as the input to the current step. So obviously, in case of RNN, there is some kind of feedback associated with the hidden layer. Okay, that means there is some kind of feedback that coming from the output to the input end, and by using this kind of feedback, we can assume that there is some kind of memory. And for this phenomenon, RNN can memorize the sequence or memorize the previous input. Okay, and it can be used for the prediction of the sequential data or time series data. In normal traditional neural network, all the inputs and outputs are the independent of each other. Okay, but in case like when it is required to predict the sequential data, let's get an example of a sequential data. Suppose we want to predict the next word. Okay, so what will be the next word of a sentence? Suppose thanks. Suppose consider a sentence. At the end, I am writing that thanks and regard. So at the end of the letter, we normally use it thanks and regard. So whenever if you use the term thanks, so obviously there will be next two word and regards. Okay, so these are the two term, the two words that will be that is needed to be predicted. So for the prediction of these two words, we need to use the previous word that has been written. Okay, so we need to remember that. Okay, so normal neural network does not utilize this feature, because here all the inputs and outputs, all layers are independent with each other. So basically did some kind of computation based on the incoming values and the weights and bias. So for this reason, normal feed forward neural network neural network are not preferable for this case. So to predict the next word of a sentence, we need to use the recurrent neural network. So let us consider an example. So here we already mentioned it that RNN basically deals with the time series data. What is the time series data? Basically, the data where the values are changed with the time. Okay, so suppose consider the stock price. So basically, the stock price can goes up and down, and the values of the stock price depend on the lots of phenomenon that goes on the around the world. Okay, so based on those facts, the value of the stocks are changing. So if we consider all the values and all those phenomenon, so we can predict the next stock value, when the stock value will go up or down. Okay, so if you sort that, so this kind of data are basically the time series data. Similarly, it's like some temperature or weather forecast, that is also an time series data. And apart from it, like the sensor reading, defined medical record that change with the time, those are also example of the time series data. So for to predict the time series data, or to deal with the time series data, we need to use the recurrent neural network, where we use the internal state or internal memory to process the sequence of the input data. Okay, and apart from it, RNN can be also used as the natural language processing, like the to predict the next word of a sentences. Okay, so coming to the basic principle, so before driving into the details of the RNN, let's go to the basic operating principle of RNN. And the basic block diagram of RNN will be look like this. So you can see that X is the input and Y is the output, H is the hidden layer or hidden state. But you can see that the output from the hidden state is fed into the input also by some kind of function. So obviously there is some kind of loop or feedback uh, between input and output. Okay, so as you can see, we can see from the above diagram that Rn contain a loop connection from to the input and to the input from the output end, and whenever we feed a sequence value, it will process each element in the sequence as the time step. Okay, so you can say that because of this feedback connection, RNN can combine the generated output with the input for the generation of the next element in the sequence. Okay, so in this way, for this presence of this loop, RNN build a memory over the time, or you can say that over the whole sequence, which can be used to make a prediction. Okay, so in order to make the prediction with RNN, we can perform the following steps. First, but to create an initial hidden state. Hidden state means the hidden layer value of H. We can say that as the initial hidden state. But to create the initial hidden state, we need to feed the first element of the sequence. Okay, and after that, to produce the updated hidden sequence, updated hidden state, we need to take the initial hidden state as well as the second element of the sequence. So you can see that the output, it also depend on the current input as well as the previous hidden state. Okay, so you can see that to produce an updated hidden state, we need to take the initial hidden state and combine it with the second element in the input sequence. At last, to produce the final hidden state, to predict the output of the RNN, we need to take the final element in the input sequence. Fine, and that will like this way it will be continued. So in this way, with the help of this feedback connection, we can teach RNN to recognize the pattern that happen over the time. So right now, let's discuss about the detailed operation of RNN. So as we already know that RNN works basically the hmm, output of a particular layer feedback into the input layer. Okay, so this one is the normal feed forward neural network structure, where there are lots of hidden layer, and each layer are independent of the previous one. That means there is no feedback. Mm, so this one on the multi-layer feed forward neural network, we can see that there are two hidden layer in this example. But if we consider the recurrent neural network, so in case of recurrent neural network, there is only one hidden state. Okay, and there is and which is denoted by the H, and there is a loop that exists into this recurrent neural network. Okay, now so and ABC, this one is the A, B and C. All these are the recurrent neural network parameter that can be used for the beta training of the RNN. So let's see how it will happen. So in case of RNN, the information cycle through a loop in the middle hidden layer. You can see that the hidden layer, there is only one hidden layer, but there is a loop exists from the from the middle hidden layer to itself. Okay, by some kind of function. So you can see that due to this presence of this loop, there is some kind of memory associated with the RNN. Okay, so that it can predict the time series data or sequential data. Here you can see that the nodes in the different hidden layers of the neural network are compressed to form a single layer of recurrent neural network. You can see that in case of normal feed forward neural network, there are lots of hidden layer, but in case of RNN, there is only one hidden layer, but that with the some kind of loop. Okay, so now let's see how it actually work. So you can see that this is actually the fully connected RNN. Here you can see that we want to xt. Let's consider that xt the input vector at the time step t. Okay, and yt is the output vector at the time step t. Okay, and ht the new state of the hidden layer, and ht minus 1 is the old state of the hidden layer, and fc the function with the parameter c. So you can see that in case of recurrent neural network, so the one input is xt minus 1, another is coming to the previous state, and you can see that based on this value xt minus 1 and the previous state, the current state has been calculated, that is ht minus 1, and based on this value yt minus 1 has been predicted. So here you can see that here x is the input layer, h is the hidden layer, y is the output layer, abc are the network parameter used to improve the output of the model. Now at any given time, the current input is combination of xt and xt minus 1. So as any time, the current input is combination of xt and xt minus. Why do we call it? So here you can see that the current hidden state, okay, or new state, if we consider the ht, so ht is basically the function of ht minus 1 and an xt. Okay, so what is the ht minus 1? Basically it is coming from the previous value, previous state that need to be stored, and it has been fetched into the current recurrent neural network. Okay, so similarly for the ht plus 1 is basically depend on the current input vector xt plus 1 and the previous state ht. Okay, so you can see that yeah, this one is the x, this one is the y, that means output, but here h the state, current state is very crucial. Okay, so how the current state is depending, basically current state is function of the previous state of the hidden layer as well as the current input. Okay, so that's why we have written that current input is a combination of the xt and xt minus 1. Okay, so basically this one is the working of recurrent neural network. You can see that yeah, xt minus 1, and the previous one is coming ht minus 2 has been coming through coming by c, and based on this two value yt minus 1 has been calculated. Again rnn has been calculated for the prediction of xt. So by using this value xt and ht minus 1, yt has been predicted. Now again we are using the previous state value ht and xt plus 1 to predict yt plus 1. Okay, so how, like this way the RNN will be RNN will operated. Okay, so this one is the basically RNN for a particular time instance. Similarly, this one is also RNN for a particular time instance. So you can see that in case of RNN, there is only one hidden layer, but there is some kind of loop associated with some kind of function. Okay, so that deals with the previous state of the hidden layer. Okay, so here it is when written again, the input layer x takes on the input of the neural network and process it and pass it into the middle layer. In case of normal neural network, this hidden layer value or weight value are independent with each other. That means there is no memory associated with the normal feed forward neural network. But in case of recurrent neural network, there is some kind of memory due to the presence of this loop. Okay, so what in case of RNN, what happened? RNN will standardize the different activation function, weight, and bias so that each hidden layer has the same parameter. And instead of creating multiple hidden layer, it will create one and loop over it as many times as it is required. So if you want to predict, like suppose n number of um, time steps. So we need to use RNN for the n number of cases. Okay, now let's get the mathematical formula for the RNN. So as you already know, if you want to calculate the current state of the middle hidden layer, so we can say that ht equal to function of ht minus 1 and xt, whereas ht minus 1 is the previous state, and ht is the current state, and xt is the input state. Okay, so based on the input value and the previous state of the hidden layer, current state has been calculated. So let's consider that what is the function. Basically f is the nothing but the activation function. It may be sigmoid function or any other function. If we consider that tan h, so in case of hyperbolic tan, so tan h, we can write that like this way: whh into ht minus 1 plus wxh into xt. So so what is WH? W is the weight of the recurrent neural end, and WXH is the weight of the input neural end. So you can see that, suppose consider this part. Okay, so there is weight associated with it. So XT into WXH. So this one is the WXH. Suppose there is the WXH in this part, and another incoming to the HT is the HT minus 1. So HT minus 1 into WHH. So WHH into HT minus 1 plus WXH into XT. And this one is the whole function of tan h, that is nothing but the HT. So that's how we will get HT. So HT is nothing but that function of WHH into HT minus 1 plus WXH into XT. Okay. So we get the HT. So you can see that from here this HT is going to the y output end. How can we calculate the output? So obviously this is nothing but yt equal to wh1 into ht. So yt is the actual output or predicted output value, and why is the weight at the output layer. So clear? I think there is three weight associated with the recurrent neural network. You can see that one weight is between middle layer and the middle hidden state and the input, and that is the WHX. Another is the current state and previous state. So that one is the WHH. So based on these two weight, we can calculate the HT. So HT is nothing but the function of WHH into HT minus 1 a plus WHX into XT. So after getting the HT, we get the YT. How? YT equal to WHY into HT. Okay. So like this way, we can calculate the actual output. Now coming to the training of RNN. So there are, so first of all, it is very simple procedure. So the network takes a single time steps of the input. If you consider the time series data, so there are lots of value at different time instant. So let's take a single value at the first time step. So now based on this value, we calculate the current state through the current input and the previous state. So we need to assume the previous state at 0. By default value, you can consider at the 0, and during the training maybe the value will be changed gradually. Now the current state of the output ht become ht minus 1 for the next state. Okay, now there can be n number of steps in the end, and all the information can be joined, and after completion of all the steps, the final step is for calculating the output. Okay, now finally we compute the error by calculating the difference between the actual output and the predicted output. Now this error is back propagated to the network to adjust the weight and produce a better outcome. Okay, so the procedure has been same. That means the back propagation of error is same, but the only difference is that how we can calculate the current state based on the current input and the previous state, based on the current state, we can calculate the current output as well as. Okay, and this process will be continued after n number of time instance or time step. Okay, so this is that's all for the training of RNN. So coming to the conclusion part, so in this tutorial class, we have learned the important concept of the recurrent neural network or RNN. Basically, it is very useful the time series prediction or to deal with the sequential type of data because it consists of some kind of memory. due to the presence of a middle hidden layer with some kind of loop. Okay, and this loop is responsible for memorizing the previous output or previous state of the hidden layer, and based on the previous state and the current input, we can predict the current output. Okay, there is uh, one disadvantage of the RNN is that the training procedure of the RNN is slightly difficult compared to the feed-forward neural network. So these are the references. So thank you. If you have any question, please post them.